delivering this lecture on behalf of Jerzy Giejewski, who had this lesson in Polish, and Julian Podgórski, who also prepared the presentation, but unfortunately he's on a sick leave. But I hope that I can cope with that as well. So today we'll be talking about drifting polar stations. We already visited permanent stations like the one in Hornsund during our lessons, and some of you will probably and hopefully visit it also in person this summer if you win our Arctic competition. And these stations are located on land, and this topic of today is dedicated to different type of facility, which is mostly a Russian or maybe Soviet specialty. It's a drifting polar station. That means it is a temporary or semi-permanent facility which is built not on the land but on the ice floe. And during especially the Cold War, the Soviet Union and the United States maintained a number of stations in the Arctic Ocean, like on Fletcher's Ice Island, for research and also for espionage. But those stations dedicated to espionage were often like more than shacks quickly constructed. But today we're going to talk about the research station, not the espionage station. So a little bit about history of Arctic studies, and on this image here you can see. Okay, I'll try to use a laser pointer. North Pole 1, first Soviet station set up by Soviet Union in 1938. And here you can see its leader, Ivan Papanin, and here on the right it's a contemporary Russian drifting drifting polar station. So an idea to use the drift ice for the exploration of nature in high latitudes belongs to Nansen, who fulfilled it on Fram ship between 1893 and 1896. And there was a lesson dedicated to Fram expedition. So just in short, since the end of the 19th century, it was known that there is no open warm sea around the North Pole, and the ice was the major obstacle for reaching the North Pole and far north in general. So any ship that wasn't an icebreaker reached up to 82 degrees north, and any attempt to go further north ended up with destruction of a ship. And the first person who thought about drifting with ice, using the ice, not being an obstacle but mean to get to north, was Nansen himself. It required a special ship, of course, that wouldn't be destroyed by ice, and it was Fram, here on the photo. Fram meaning forward in Norwegian. And in 1893, at the end of the 19th century, Nansen left from Norway to New Siberian Islands. And then the ship was frozen into the ice and drifted to Spitsbergen. There it left ice and calmly traveled back to Norway. And it was a scientific, successful trip. So here you can see the Fram frozen into the ice cover of Arctic Ocean. And his route is marked here in yellow. And since this Fram expedition, not many people were interested in continuing this until the 1930s. Exactly on January 13, 1936, Joseph Stalin called to Kremlin an aviation ace, a Polish guy, Zygmunt Lewoniewski, and asked him, what should I do to make flights over the Arctic safe? And Zygmunt Lewoniewski answered that shared his idea of opening at the North Pole the world's first year-round research station that And he said that the results of the experiments conducted there would be used by aircraft designers and to enable to prepare meteorological maps. And Stalin liked the plan, and he made an immediate decision to implement it, and the very next day a team of the best Soviet polar explorers was formed. There was a commander of the expedition, Ivan Papanin, and meteorologist, and radiotelegraph, and hydrobiologist. So then the station equipment was completed, and the station was simply called North Pole. Then it was called North Pole 1 because it was followed by other stations. So, like I said, after Fram, no one wanted to drift until 1930s, but then there was a decision to put a station on ice, and here's a photo of a team of aviators, and who with airplanes set up a base on the pole. It was a tent-based station. Here you can see the tents with several measurement devices around, and mainly it was used for meteorology and hydrology, to measure temperature, to measure ice movement and water currents. And Russians were particularly interested in importance of ice for the northern route, a route for ships along the northern coast of Siberia, to dominate in this area, of course. And about the preparations for setting the base, you remember it was 1930s, but the preparations were very, very intensive. For example, clothing. They had underwear made from, in accordance with recommendations of a German biologist, Gustav Jager. They were made of skins of reindeer calves. They had sweaters made from the fur of Siberian wolves to make it very, very warm. And they had Orthodox nuns to make traditional fur blankets to keep them warm. So maybe it's not Gore-Tex that we are using today, but they were very well prepared. And no less attention was paid to provisions. And 5 people were gathered for 500 days and for 500 tons of food, and including many instant products. Now, today, instant products are no wonder for us. We use it on daily basis, whether they're very healthy or not. But then in 1930s, it was a novelty, and 5,000 hens, 5,000 chickens were killed to make a meat powder for instant food. And there was a pea soup, red jelly in form of powder. So freeze-dried products and vacuum-dried products were not so popular at the time. So those light briquettes, which are used with boiling water, after pouring boiling water, arouse giant emotions that this is like cosmic technology. And for 274 days, the team on this first North Pole drifting station was doing research. Like I said, the tents were surrounded with measuring devices. Like here, you have a currentometer for measuring ocean currents, for example. Okay. And after 274 days, when they returned, Ivan Papanin, the commander, the leader of the station, became the hero of the USSR. You can see all the medals. So it was the highest possible distinction. He got to meet Stalin and became a national hero. So after 1937, after the success of the station, the Russians started doing the station every year. And they were collected by icebreakers wherever they got to reach. And here are the routes of very late stations, like in the year 2000 and later. And you can see how differently stations can flow. For example, the green one from Greenland to Russia. Other stations, different ways, different paths. And all of them are a source of valuable weather and hydrological info in a different way than a stationary station that is permanent, that is located in one place and on land. Here you can see the new stations, like since 2002 there is a Borneo station, which is quite specific. Here you can see it from a closer distance, a closer look at Borneo Station. Like I said, up until today, they are built every year. And in 2001 and 2002, the competition showed up. And competition in the meaning that private investors wanted to do some bases, but tourist bases, close to the North Pole, for so-called extreme tourism. So Borneo Station was established only for March and April, but had flight connections to Spitsbergen, and tourists can go there easily from Longyearbyen. They're plane to Borneo with a helicopter to the pole. So very easy, but still extreme tourism. You go to Borneo Station, take a helicopter to North Pole, take a photo, and come back home. But also, the station is also used to reach North Pole in a simpler way than usual. So for many people, the station is the starting point for a trip. But they do not use helicopter to get to North Pole, but they go by walk. So they're dropped somewhere and go by walk. And like I said, you can get to Borneo straight from Longyearbyen on Svalbard. And sometimes polar expeditions use Borneo as a base. So on the left, there are routes covered by many expeditions that stopped at Borneo only in 2015. So it's not only a touristic base, but also plays a scientific role. And on the right, it's interesting, this is a map of a drift of recent Borneo bases. Because we have to remember, these are drifting ice stations. They're not located only in one place. They change their location, which depends on currents, winds, etc. So these are the routes of drifting in 2014, 2015, 16, 17. So each year it is different, it's changing. So as you can see here, lots of people choose this extreme form of tourism. These are tourists on North Pole, around North Pole, who got there thanks to Borneo Station. And Borneo owners started to look for some cooperation too. For example, you can see here Russkoye Geograficheskое Общество, Russian Geographical Society, started cooperation with Borneo owners, and so it started in September. Until March, it is scientific. Only then, until April, tourists, and later tourists again. So now it has two roles, touristic and scientific too. So sometimes weird things happen in Borneo. For example, North Pole Marathon takes place since 2012. In the beginning, there were only 3 people taking part, and now a few dozens yearly join a marathon near the North Pole at the Borneo Station. And another form of extreme tourism, extreme sports. It's a base for extreme sports like polar diving under the ice. We said that drifting polar stations are mainly Russian or formerly Soviet specialty, but not only. They're not exclusively Russian. Here are stations that are also run by Danish and Norwegian team at the tip of Greenland and in a very interesting location from a geological point of view, which means Lomonosov Ridge. And this is the area of operation of so-called Green Ice project. So stations in the Green Ice project are usually small, you can see them here, and surrounded by a large strip of cleaned ice. This cleaned ice for what? To allow airplanes to land, because they're supplied by airplanes. And researchers get to green ice by plane, and here you can see loading of supplies onto an airplane on its way to the station. But in the very beginning there is nothing but ice. This is how it happens. People who build it needed to construct a camp, get there in the middle of nowhere, surrounded by ice only, and construct a camp like this, with shovels. And so a few people landed there on airplanes, then built a base, and then implemented a scientific program of meteorology and also oceanic bottom studies. So here we can see them, researchers at work, people who take samples from the ocean bottom, from seabed. This probe is lowered to the bottom, retrieves a few meters of sediment from the bottom. Here's another equipment, another probe to get samples from the bottom. And other studies are conducted there as well, like seismic studies. Here we can see compressed air as source of signal and compressor to charge them. These are exactly seismoacoustic studies. And the results of these studies are quite extraordinary. Like for example, we have a direct profile of ocean bottom structure. Those lines are different layers of oceanic bottom. We still do not know exactly how is Lomonosov Ridge built, but this geological interpretation of those sediments we got to collect is allowing to do so. So those stations in green ice camp drift only about 100 kilometers and work for relatively short time. And what is interesting, not only oceanic bottom, but also depth of ice cover, thickness of ice cover is studied by those stations and by submarines used by those stations beneath the ice. You can see that it was from thickness of ice cover studied from 2004 up to 2007. And so the maximum thickness is north of Greenland, and then it's thinning to east, towards east. So submarines are used there as well. And analysis of satellite photos of Arctic Ocean and combined with studies conducted by drifting stations allowed to find particularly thick, constant places made with ice, like ice islands. They're very, very durable. They do not thaw, they do not melt, but we do not know exactly why. And in Northwest Passage, there is an island that was observed for over 12 years, and it was drifting, and the black line here is the route of its drifting. And so most drifting polar stations built on sea ice have to be are not durable, have to be dismantled because the ice beneath them fails when it gets warmer and it gets dangerous to remain there. But USA put a station on this island drifting here in Northwest Passage, this particularly thick island, for 2 years because they had this valuable long data set, and no other station could obtain data for such a long time because they could remain there for 2 years. It was from 1962 up to 1964. And this station was a Fletcher Ice Station, was much larger than the others because Americans had a guarantee of ice stability, so they could do it. They could make more permanent buildings, we might say. And the last idea for a drifting station was to somehow repeat Nansen's idea, repeat Fram's trip with a craft, with a Hobo Craft. This is a Hobo Craft. A Hobo Craft is a quite universal vessel because it can float over water and also float over ice, so it's very useful in this kind of expedition. Some construction changes were made so that when iceberg on which the craft lies is disintegrated, it could return home with even 1,000 kilometer change. This is a part of Fram project from 2014-2015. And this is the interior of this Hobo Craft, back of the ship. This is how it looks like, and front of the ship. Maybe not very comfortable. And but it doesn't need to be big because it only has a 2-person crew. It was transferred to Eastern Arctic Ocean by a giant, famous German icebreaker, Polarstern. It means Polar Star. A giant icebreaker, which is which has a large range of operation. It means that it can operate even at -50 centigrades, -50 Celsius degrees. It's a very good science icebreaker, widely used in the Arctic, in the Antarctic, and it brought this Fram Hobo Craft to its mission. And these are 2 people that were on board of this Hobo Craft. 2 Norwegian people with craft and their supplies. They were left for a 9-month expedition on this tiny Hobo Craft. But they were not left totally alone because there was a possibility to add supplies with an airplane. So they did not take everything they needed at once for a 9-month expedition. This was just for a while. So they were supplied from airplanes. In summer 2014, Polarstern, this icebreaker, worked here in those green areas, here and here, and Fram worked with it. It was measuring ice thickness. But in autumn, Fram left on its own and drifted to Spitsbergen. This is interesting because this is a wall of ice built by those researchers to avoid covering the ship with ice and snow. So it was like an ice garage for the Hobo Craft, built with ice bricks. So around this craft, some measurement devices were set up to measure currents, to measure chemistry of water, temperature of water, meteo station, geophysical bottom profilers and sampling probes. You can see that they're reaching the bottom of the ocean, so there's a probe. Here's a currentometer, and there are some seismic studies. So even with this tiny craft, it was widely used for a wide range of different research. What happened during the polar night? We're in the polar region above the Arctic Circle, so there's a polar night as well. And during the polar night, aside of covering the machine, tents and snow constructions were built to allow for work with instruments regardless of the weather, the harsh weather. So the ice thickness was measured too, and but it was all covered with snow constructions. But actually, it was, I can come back to that, it was possible to work during polar night. You can see this full moon, so it was quite bright despite it was night all the time. Here's one of the crewmen of the craft, Professor Fridtjof Nansen. Here he's using the oceanographical probe, lowering down to the ocean. So you can see here the ice is not that thick, but the thickness differs. Okay, what's going on? And once he put this probe under the ice, the camera from a bottom probe took a photo of a fish under the sea. So remember, it was a 9-month expedition, and this is a week 9 expedition piece of report, because Fram 2014-15, this craft had a good satellite connection, so they were not totally isolated, and they could prepare weekly reports of the trip about how they flow, and the results of the experiment. So the results were available in the internet, not only for scientists but for everyone. And it was a great difference from all the other projects, because the results were publicly shared. Their journey was publicly shared, and scientific results were publicly shared. While Russian results from Russian drifting stations have very limited access. So this is from week 5, I think. As you can see, the weather can be sometimes really, really harsh, and imagine remaining like this for 9 months. Oh, this is what I was talking about, that sometimes the weather wasn't that harsh. It was calm and nice during polar night, full moon here, so you could work in the field. It was quite bright, and as you can see, it's freezed into the ice. The whole vessel is freezing to the ice. Here you can see the route marked in red, route of the Hobo Craft Fram. Almost a year, like I said, 9 months, between leaving Polarstern, and it is here, and disintegration of the iceberg on which it was settled. So craft traveled to Spitsbergen, and Norwegian icebreaker collected items that were left on ice, and Fram left easily. So the route is like this, and it can be hardly controlled by the vessel. So it's a result of winds, currents. It's never simple and never 100% predictable. So they traveled, as you can see, here's a Lomonosov Ridge. They traveled along the Lomonosov Ridge, which is good, because Lomonosov Ridge is seen as a border of Eurasian plate, and also a basis for territorial claims in this area, or mainly of Russia. So the thing that it was traveling and drifting along the Lomonosov Ridge was important also from scientific point of view. But living on drifting ice stations is not always so easy. It may be quite dangerous. It sometimes is. In August 2016, Station North Pole 15 was in August 2015, Station North Pole 15 was evacuated because ice thickness of the ice on which the station was settled decreased 16 times. So there were some serious ice cracks, and the scientists kept meeting thawed tolls around the facility, so it became really dangerous. So these are the photos of the evacuation of this Russian station. So researchers were safely evacuated by airplanes, and there was a helicopter no, of course, not only researchers, but also heavy laboratory equipment, and it was all safely evacuated from the station. Like this tractor, which was designed for icy conditions. So, as you can see, it may seem like a great ice adventure, but sometimes external assistance is needed. And also the fact that the sea ice thickness decreased 16 times and it became dangerous for the station. It is also a sign of climate change in the region. So this is all that I had for you today.